Hello, this is going to be a quick code walkthrough for Lab 11. The objective for this lab was to write a driver for the LCD with the code that the instructor provided us and basically make a draw line function, which is what I've done here. So I'll go ahead and talk about how I did that. Um, so basically I have the declaration for this draw line function. The input parameters are the color for the line that you want to draw, and then the starting x and y positions, x1 and y1, and then x2 and y2 are the ending positions for that line. What I start off by doing is by saving the original x and y values. I put them into these variables, um, and then the thing I need to do next is calculate the slope. You'll notice that I calculate the slope with the denominator being an absolute value, and I'm calculating both a y slope and an x slope. The reason I'm doing this is because when it comes to floating point gradients, since we're using integer arithmetic, the STM32 board starts to run into a few problems where it is not very good with because of the pixel constraints. Basically, you can't have floating point addresses for the pixels, so you need to decide whether or not you need to interpolate the line with samples on the y-axis or the x-axis. And if your floating point value is if your gradient value is a floating point number, that means you need to interpolate it with x values. So I'm doing that, so I'm calculating both the x slope and the y slope, which is basically delta x per y or delta y per x. And the reason I keep it as an absolute value is because I have a separate value, which I'm calling x delta, which determines the signedness of um, either x or y. So if the starting position of x is less than the starting position of the ending position of x, then we have a negative delta, which means we need to subtract every single time we iterate. And if they're both the same, then we know that we don't need to increase or decrease x. And then I have a default value of 1 in case the ending point is greater than the starting point. And then I do the same for y. So I begin by putting the starting values in the offsets, and then I set the address for a single pixel, and then I push the color to that pixel. That's pretty straightforward. That's the very first pixel in the line. We need to do this to get started. Um, so the next step is to basically sit in this while loop while we haven't reached the ending points. So while either of these conditions are unfulfilled, we keep iterating. And basically what I have is inside this while loop, I have an if statement that checks to see where if the gradient is dependent on y. So for instance, if we have a gradient of 2 or a gradient of negative 2, we know that for every unit of x, there's 2 units of y that are changing. So if we start off at 1, 1 with a gradient of 2, the next location on Cartesian coordinates would be 2, 4. 2, 3, for instance, right? That would give us a gradient of 2 with the y. So what I need to do in this scenario is increment x once, but I also need to draw the missing pixel in between for y. And that's kind of what this is doing here. So if the gradient falls in that category, I sit in a loop and have an integer for the current pixel that I'm at. I set it to the delta value here, and while it's not equal to y slope plus y del, I increment by y delta every single time, and then I keep drawing these pixels. And it's kind of hard for me to explain, but in my head it makes sense. we're basically keeping x constant while we're increasing y, because for every 1 unit of x, we're changing 2 units of y. So we're keeping x constant here, but we're incrementing y another time before we um, go ahead and finish drawing this portion of the line. So every single time x changes once, we need to change y twice. So that's what this loop is doing. Similarly, I have another loop for x that handles the same um, scenario where if you have a floating point gradient, what happens is for every unit of y, you're changing x maybe twice. So here you keep y constant, but you increment x twice. And it's the same kind of loop here, except I'm using, as you'll see, I'm using x, um, the associated variables with x. And then finally, at the very bottom, I have this if catch statement where I'm incrementing both x and y if they haven't reached their endpoint. And um, once this while loop resolves, all of the coordinates that fall on that line should have been drawn. So it takes care of that for us. And that's about it. So the last thing I do here is I pop the values back in from the original, and that puts the x and y coordinates back to where they were before the function was called. And that takes care of all of the lines that we draw. For our main, I basically have this loop that the instructor provided us. I changed the colors. I think these were white and black before. Changed them to red and blue. Excuse me. And then I basically I'm drawing a crosshair type thing with 15 with a length of 15 on each side. So this is starts at 80 and 64, 95, 64, so on and so forth. And then from here I have these 4 lines are gradients of 2. So you'll notice for every unit of y that changes, I'm changing 2 units of x. So then it works out to 110 minus 80, 79 minus 64 divided by 110 minus 80. And that gives us a floating point slope, and that's where this guy comes in, this loop here. And it handles that for us perfectly. And then I kind of do a similar thing here where this works out to 49 minus 64 divided by 110 minus 80, and that again gives us a slope of -2, and then these two both work out to +2, I think. But yeah, that's basically how that works. I haven't made many other modifications to the code aside from that. The only other change I had to make in the end was I added these 2 includes in the header file for the LCD driver, and that was because I wanted to do these absolute values and ceiling functions. I was getting warnings for implicit definitions, and I wanted to get rid of those. So I went ahead and included these in the header. But once I did that, everything looked to be working fine. I think I covered everything for this lab. Let me know if I missed anything, and I'll be happy to get back to you on it. Thanks.